Many times it's not enough for us to just factor an equation. What we actually want is the solutions to the equation. The solutions for an equation can be thought of as a couple of different ways. The first way to think about it is that they are the x values that make our equation equal to 0. So if I have x squared plus 3x plus 2 equals 0, this is called standard form when our quadratic is set equal to 0. And it's the way that we always have to get our quadratic set up before we can use factoring in order to solve it. What we're looking at here is a quadratic that's set equal to 0, and I want to know what does x have to be so that this side of the equation equals 0. So I guess one way to do it might be to go through and try to find every single number that you could plug in to get 0. But there's an infinite number of zeros or an infinite number of numbers rather, and it could take quite a while for you to be able to find it. Plus, there's two answers because it's a quadratic, so it would take even longer because you got to find two of them, not just one. So instead of just going through and randomly trying to check numbers, what we're going to do is we're going to use factoring as a way to set up smaller equations to figure out what x needs to be. So if we factor this equation, we end up with x plus 1 times x plus 2 equals 0. Now, if you don't remember how to factor, you should probably check out the other video because I'm not going to show that here. Now we have two factors that are equal to 0. The nice thing about having two numbers that are multiplied to 0 is that if either one of these, either the second or the first term, is equal to 0, the whole thing is equal to 0. Just like 0 times 1 equals 0, and 1 times 0 equals 0. So what I need to do is I need to force these to be equal to 0. The way I'm going to do that is to rewrite a new equation. So for this one, I will say x plus 1 does equal 0. I'm not giving it any choice. Now all I have to do is solve this linear equation, and I have one of my solutions. Anytime you're trying to solve for x, you look at what else is going on in the equation, and you try to do the opposite. Here we've got a plus 1. So in order to find out what x is, we need to subtract 1 from each side. Now we get x equals negative 1. So we're halfway done. That's one of our solutions. Okay, well, what if this one isn't equal to 0, but I still want the whole thing to be 0? Well, in order for that to happen, I got to set this one equal to 0. Again, don't even give it a choice. X plus 2 equals 0. Now we go through the same steps as we did over here. Subtract 2 from both sides, and I get that x is equal to negative 2. So I've got both my answers here. X equals negative 1, x equals negative 2. Let's look at another problem. How about x times x plus 2 equals 0? So this is already the factored form of this problem. X squared plus 2x equals 0. So since this is already factored, all we have to do is take my two factors and set them equal to 0. Now, just because this x doesn't show that it's in parentheses, doesn't mean you can't draw them there. Remember, you can group it inside of parentheses if you want. It's just multiplication. So I'm going to set each factor equal to 0. First, we've got x equals 0. Well, that one's pretty easy. It's already solved as soon as you write it down. X equals 0 is one of my solutions. The second one, x plus 2 equals 0. We have to do a little bit more work, but not a lot. It's actually the exact same as the second factor up here. So if I subtract 2 from each side, I get that x is equal to negative 2. So my two solutions are x equals 0 and x equals negative 2. All right, how about one where my answers won't be integers? Let's look at 3x plus 2 times 2x plus 1. And of course, equals 0. Since it's already factored, all I need to do is set each factor equal to 0. 3x plus 2 equals 0. The first thing here, I want to deal with addition or subtraction before I try to tackle the multiplication. So let's subtract 2 from each side. That leaves me with 3x equals negative 2. Now you may be tempted to stop here, but we're not quite done yet. X doesn't equal negative 2. 3x does. So what I need to do to get x by itself is divide both sides by 3. That leaves me with x equals negative 2/3. Leaving it as a fraction answer is perfectly fine. I know some of you prefer decimals, but honestly, fractions are usually much better. So now let's look at the second one. We've got 2x plus 1 equals 0. The same steps here. Subtract 1 from each side. I've got 2x equals negative 1. Now I need to divide by 2. So I'm left with x equals negative 1/2. In this case, I end up with two answers that are fractions instead of decimals, or sorry, instead of integers. If you look back at our original factors, you can always tell if it's going to be an integer or not. If the number in front of x isn't either 1 or the same number as this last term, or I guess if it's not an even factor of it also, but basically you can take this last term, divide it by the first term, and that tells you whether you're going to have an integer or a fraction. When you take the last term divided by the first term, if it's an integer, well then your answer x is going to also be a whole number. If it's not, like it isn't here, 2 divided by 3, we get 2/3. You can also, sort of as a shortcut, if you take this term, switch the sign, so it's a negative 2 divided by the first term, then we get negative 2/3. Well, that's our answer down here, right? So if you're not really comfortable with that shortcut, that's fine. Just work through the steps until you see the pattern for yourself, okay?